Hello, I'm here to talk about acceleration. Acceleration is that gut feeling that you get when you're sitting in your car and you have it going really fast, but you stop it abruptly, or when you start it going really, really fast. Now, when I was a little girl, that feeling was really cool. I really liked it. And I used to fantasize about being in a car that accelerates a lot until I realized that people in that situation are only comfortable in movies and TV shows. So I moved on, and I started thinking about being accelerated in a gigantic rocket. I mean, who hasn't thought about it? And as it turns out, rockets are really hard to accelerate. They are enormous, and they're really, really heavy. So that was where that dream stayed. And so I forgot about rockets and cars, and I thought, instead, of accelerating the smallest, lightest thing that we have in our universe. So that's the electron. The electron is, in another way of saying it, what you get when you start cutting down to pieces and you keep going until you can't cut no more. That's an electron. And it's really important to accelerate electrons. And if you don't know why, it is because they give us light. That's how we generate light. And we need light for all of the things that we do in our daily lives, right? But I am interested in a very powerful type of accelerator that accelerates electrons so much that the light that comes out, the radiation, is so intense and has such a quality that it allows us to study little animals like our friend was looking at before. And it allows us to help support patients who are struggling against cancer through radiotherapy, for example. Now, although it is obvious that it's very important, these accelerators are also very, very big. That makes them very, very expensive. And for people in countries, for example, like my own, I'm from Portugal, which is across the ocean from here. For people in countries where maybe the medical or research budget is not large, they cannot have access, they cannot afford to have access to this radiation. And that is a problem. And the solution is what I'm working on. I'm working on the DREAM accelerator. And the secret ingredient for this accelerator is a plasma. Now, I'm not talking about the plasma blood that you have flowing on your veins. It's not that. I'm talking about a special type of gas that can produce light. Now, there are two things that are very important about this gas, and that are the reason why the accelerator is so good. One of them is that it shields the accelerator. So we can make it really, really powerful, and it's not going to melt or explode. And the second reason, and this is the most important one, is that the little parts of the plasma gas, they work together. And what I mean to say is that if in your normal accelerator, you have the electron that's going really fast, trying to reach its goal line, when you add the plasma, what you're doing is you're getting this collective work being done, trying to push that electron towards the goal line much faster. And that means that I need only a plasma, maybe the size of my hand, to get the radiation. And so now that you understand what the DREAM accelerator is, I'll tell you that what I do to get there is go to different national facilities to do experiments, try to test our initial concepts. And I work on very large computer simulations to try and understand the complex phenomena that are happening inside the accelerator. And to do this, I kind of have my own personal plasma, so to say. So these are the team I work with here at Stony Brook and all of our collaborators from around the world that together help me, help accelerate me so that I can reach my goal much faster. And that goal is to take that DREAM accelerator and the one that will be affordable and possibly available everywhere to everyone who has need and make it real. Thank you.